Okay, for 9.3, we're going to learn about trig functions and any angle. Alright, so this is the second half of 9.3, part 2. So we're going to start with reference angles. So each angle has a reference angle that is acute. Anybody remember what acute means? Less than 90. And it is positive. So the reference angle is always going to be acute and positive. Now to find the reference angle, we call our reference angle this little symbol here. So it's like theta with a little dash above it. We call it theta prime. That's just a name for our reference angle. To find our reference angle, if we are in the first quadrant, so this is the first quadrant over here, whatever our theta is, our reference angle is the same thing. In quadrant 2, which is the one in the top left, our reference angle, so theta prime, is 180 minus whatever our theta is. If we're in the third quadrant down here, our reference angle, so theta prime, is theta minus 180. And if we're in the fourth quadrant, our reference angle is 360 minus theta. So this little picture here that I drew is all of these put together. So it's just all of them in one picture. So it's what shows this is quadrant 2, quadrant 3, quadrant 4, and it has the formulas down here. The formulas on the bottom here are in degrees and radians, but we're always going to change it to degrees because it just makes our lives so much easier. So we'll see in the first example why we change it to degrees to start, so we don't even have to worry about the radians formula down here. We're just going to be looking at the one that has to do with the degrees. And then if you just put them all into one little chart here, that's all you need to look at. So on your notes that you'll have for the test, you want to have this box here. It's just so much easier. So let's take a look at our first example. So example 3a. So it gives us 5 pi over 3. Do we know where 5 pi over 3 lies on our coordinate plane? So this is why we change it to degrees, because it's so much easier to tell which quadrant it lies in when we're dealing with degrees, because we know that our first quadrant is from 0 to 90, second quadrant is from 90 to 180, third quadrant is 180 to 270, and the third is 270 to 360. So we want to change this to degrees so we can easily see which quadrant this lies in, and then we can just use our little formulas from the last page. So how do we change this to degrees? We multiply it by 180 over pi. Remember, when converting, you're either going to multiply it by pi over 180 to go to radians, or 180 over pi to go to degrees. So we multiply it by 180 over pi. Pi's on top, cancels out with pi on the bottom. And we can divide 180 by 3, which leaves us with 60. So we just have 60 times 5 on the top. What's 60 times 5? 300. So we're dealing with 300 degrees here. So what quadrant does 300 degrees lie in? The first, the second, the third, or the fourth?
The fourth.
The fourth. It's over here. So this is a 300 degree angle here. And now we're in the fourth quadrant, so what formula do we have to do to find our reference angle? So our reference angle is equal to what?
300.
Go back to the last slide. Remember, if we're in the fourth quadrant, we do 360 minus theta. theta is the angle we're talking about. So we have 360 minus 300. What's 360 minus 300?
60.
60. Is 60 degrees acute and positive?
Yes.
Yep. The only thing here, though, is that since it gives our question in radians, we need our answer to be in radians too. So we actually have to convert this back to radians. So what do we do? What do we multiply this by to convert it back to radians? Pi over 180. So this would be 60 pi over 180. We can cancel out the zeros. The 6 goes into 18 3 times, so we're left with pi over 3. So pi over 3 is our reference angle. All right, let's take a look at B. So here it gives us theta is equal to negative 130 degrees. Whenever it gives us a negative theta to start out with, we don't like to work with negatives, just like we don't like to work with radians. So we want to change this to the positive coterminal angle. So negative 130, we would start from our initial side here, and then go down 130 degrees, which would put us over here in the third quadrant, but we really only want the positive angle. So how do we find what our positive angle here would be? Our positive coterminal angle of theta here. What do we need to do? Anybody remember how we find our positive coterminal angle? We did this before spring break. To find our positive coterminal angle, we're going to add 360 to negative 180. Negative 130, sorry. We're adding 360. So it's negative 130 plus 360.
230.
230. So 230 degrees is the same angle as negative 130. We're just going in the different direction. We like to work with positives here. Now, what quadrant is 230 degrees in? First, second, third, or fourth?
Third.
The third. So when we're in the third quadrant, what is that formula that we need to do to find our reference angle?
Theta minus 180.
Theta minus 180. Our theta here is 230. So we have 230 minus 180. What's 230 minus 180? Perfect, 50. So our reference angle is 50 degrees. Our question gave us degrees, so our answer has to be in degrees. So we're in degrees. We don't have to convert this to radians or anything. We'll just leave our answer in degrees. Is it positive and acute?
Yeah.
Yep, so we're good. All right, next we're going to be evaluating trig functions anywhere in our coordinate plane. So we use these steps to evaluate a trig function for any angle theta. So step 1, super important, which we just found out how to do, is find the reference angle of theta. So step 1 is exactly what we just did in the last couple examples. Find our reference angle. Next, we need to evaluate the trig function for our reference angle. And then step 3 is determine the sign of the trig function value from the quadrant which theta lies in. So we have this little chart here that tells us where each trig function is positive or negative. Another way we can look at this, a little helpful shortcut here, is in a coordinate plane, quadrant 1 all trig functions are positive. Quadrant 2, the sine trig function is positive and it's reciprocal. So that means sine and cosecant are positive. Quadrant 3, tangent and cotangent are positive. And quadrant 4, cosine and its reciprocal are positive. So cosine and secant. So one way that you can look at it is all students take calculus. Starting with quadrant 1, all of them are positive, then sine, tangent, cotangent, cosine. And then the reciprocals just go along with it. So this is a little helpful shortcut to think about it. All students take calculus. So we need to evaluate tangent of negative 240 degrees. So first thing we need to do is find our reference angle. So let's figure out where this lies in our coordinate plane here. Negative 240, we go from our initial side and down. So I believe it's over here. No, it's actually
Upper right.
I think upper left. But we'll find the positive and double check to make sure that it's supposed to be there. But I think it's going to be over here. How do we find the positive coterminal angle for negative 240?
Adding
Add what?
360.
360. So what's negative 240 plus 360?
My iPad just crashed. Hold up.
Anybody else?
120.
120. So 120 puts us in the second quadrant. So when we're in the second quadrant, how do we find our reference angle? What's our formula?
180 minus theta?
180 minus theta. So our reference angle is 180 minus 120. What's 180 minus 120? 60. So our reference angle is 60 degrees. Now we want to find the tangent of our reference angle, so the tangent of 60 degrees. So using that little box, tangent of 60 is square root 3. So our answer here is square root 3. So you have to use that box from 9.1 to help you solve these problems. Any questions there? All right, let's do the same thing for B. So step 1 is find our reference angle. What do we have to do when it gives it to us in radians?
180 over pi.
Multiply by 180 over pi. So the pi's cancel. We can divide 6 into 180 30 times. So we have 17 times 30, which gives us 510. So we go around the circle once completely. And then how many left over do we have once we go around the circle once? We went around one full time, so we can subtract 360 from 510. And that gives us 150 left. So we're going to go another 90 and then another 60. So we're over here in the second quadrant. So when we're in the second quadrant, how do we find our reference angle?
180 minus theta.
180 minus theta. So our reference angle is 180 minus theta. What's our theta that we're going to use here?
150.
150. Perfect. So 180 minus 150. What's 180 minus 150?
30.
30. So we're looking at 30 degrees here. And we're finding the cosecant. So cosecant of 30 degrees. So using that chart, cosecant of 30, what did we say it was? 2? Yeah.
Yeah.
So 2 is our answer. For these questions, you can put this into your calculator to check your work, but the whole point of this is solving it without using a calculator, so I need to see your work. So if you want to check yourself at the end, make sure you did it right, you can put this into your calculator. But for these questions, I need to see your work. I need to see all the steps worked out. I need to know what your reference angle is and what angle you're looking at on that chart. So going back to example 4, I forgot all students take calculus, this little thing here. So in our first quadrant, all of them are positive. In the second quadrant, sine and its reciprocal is positive. In our third quadrant, tangent and its reciprocal is positive. And in our fourth quadrant, cosine and its reciprocal are positive. So in example A here, what quadrant are we in? The sine quadrant.
Sine.
We're in the second quadrant. So just sine and its reciprocal are positive. So what does that tell us about tangent in the second quadrant? Is it positive or negative?
Negative.
It's negative. So I forgot to make it negative. So we have a negative square root 3 as our answer.
Okay. What's the all then?
All of them are positive.
Oh.
So in the first quadrant, everything's going to be positive. So here we have all students take calculus. Which quadrant are we in here?
Sine. So
The sine one.
positive.
So sine and its reciprocal are positive. So that means sine and cosecant are positive. So this is a positive 2.
So at the end, just go back to the chart and then check what.
Yeah, we just have to check our signs. So like step 3 on the slide before this that explains everything is check your signs. So I completely forgot step 3. So don't forget to check your signs. So we're going to do 5 and 7. So let's take a look at 5. First thing we need to do is sketch the angle. What quadrant would 210 degrees be in? The third quadrant.
Okay.
So it's over here. What is our formula for our reference angle when we're in the third quadrant?
Theta minus 180.
Theta minus 180. What's our theta?
210.
210. So 210 minus 180. What's 210 minus 180?
30.
30. So our reference angle is 30 degrees. These problems aren't too bad when it gives you a positive number in degrees, but it gets a little bit tricky when it's a negative number or if it's in radians, because it's just a little bit more work, but it's not too bad. You just have to figure out which quadrant you're in and then use the formula that goes with it. So let's take a look at number 7 now. So this one's negative and in radians. What do we do if it gives it to us in radians? Convert it to degrees. So what do we have to multiply to this to change it to degrees?
180 over
180 over pi.
over pi.
Perfect. So the pi on top cancels out with the pi on the bottom. And we can divide 9 into 180 20 times. So So we're left with negative 7 times 20, which is negative 140.
Is it always 180?
Yes. Anytime you convert it, it's always going to be either 180 over pi or pi over 180.
When is it pi over 180?
When you're converting from degrees to radians, it's pi over 180. So this negative 7 pi over 9 is the same thing as saying negative 140 degrees. But we want to work with a positive angle. So here, negative 140, if we start at our initial side and go down negative 140, that puts us over here. But we want to figure out what the positive version of this is. So how do we find the positive coterminal angle here?
Add 360.
Add 360. So we add 360 to negative 140, and what do we get?
220.
220. So 220 puts us in the third quadrant, just like we said. So what's that formula that we need to do when we're in the third quadrant?
Theta minus 180.
Theta minus 180. What's our theta here?
220.
220. So 220 minus 180. What's 220 minus 180? 40.
40.
So our reference angle is 40 degrees. Are we done?
No.
Nope. What do we need to do?
Multiply it. I think pi over 180.
Perfect. We got to multiply it back to radians, so we multiply it by pi over 180. So we can take 10 out of the top and the bottom, so we're left with 4 pi over 18. Can we simplify this anymore?
No.
Does anything go into 4 and 18?
Oh, 2.
2. So we can divide the top and the bottom by 2. So we have 2 pi over 9. That's your answer. So let's look at number 9. What's the first thing we need to do here for number 9?
Find the positive version of it.
Find the positive version of it. Perfect. So how do we find the positive coterminal angle here?
Adding 360.
Add 360. So it's 210, negative 210 plus 360.
150.
150. So we're going around 150 degrees. That puts us over here. So we're in the second quadrant. What formula do we use in the second quadrant?
What is this thing called? Theta minus 180.
Theta minus 180 in the second quadrant?
Or 180 minus theta?
180 minus theta. And what's our theta here?
150.
150. So 180 minus 150 gives us what?
30.
30. So we're trying to find the cosine of 30 degrees. So go back to that chart. What's the cosine of 30 degrees? So that is our answer. Again, just like I said before, you could put this into your calculator, but when you put cosine of negative 210 in the calculator, it's not going to give you square root 3 over 2. It'll give you some decimal version of it. It'll be whatever square root 3 over 2 is in the calculator. But I need to see all your work, so don't just put it in the calculator. All right, so let's check our signs for this one. We have all students take calculus.
Positive.
We're in the second quadrant, but here we have cosine. So what is cosine in our second quadrant?
Negative.
Cosine's negative because only sine and its reciprocal are positive. So this is a negative square root 3 over 2.
Wait, I'm confused.
we're in the second quadrant here. So in the second quadrant, we have sine and its reciprocal, which is cosecant. But we're looking at cosine here. We're taking the cosine of 30. So everything besides sine and cosecant are going to be negative. So that's what makes this negative. We need to see what trig function we're dealing with. Here we have cosine. And in our all students take calculus, where does it fall? And does it make it negative, positive or negative? Here it makes it negative. So all we do is change the sign of our answer. All right, we have time for one last one. Let's look at number 10. So what do we need to do first here?
180 over pi.
Multiply it
180.
by 180 over pi. So we're going to change it to degrees. So the pi's cancel. We can divide 4 into 180
45 times?
45 times. So we have 45 times 11, which is 495.
Oh, I could all be wrong.
So 495 degrees. It's bigger than 360, so we're going to go around the circle one time. But how much more do we have left to go?
855. Whoa, that's definitely wrong.
Lexi,
135.
perfect. You added 360, but we're supposed to subtract here to find how much left we have left to go. So we subtract 360, and we have 135 left to go. So we're going to go 90 more and then 45 more over here. So what quadrant are we in?
Sine?
Well, yeah, but 1, 2, 3, or 4?
2.
2. How do we find our reference angle in quadrant 2?
180 minus theta.
180 minus theta. What's our theta going to be?
135.
135. So our reference angle is 180 minus 135, which is what?
45?
45. So we need to find the secant of 45. So let's go back to our chart. So looking at the chart, we get square root 2. And then we need to figure out if it's positive or negative. So we're going to do our all students take calculus. We're in the second quadrant over here. So only sine and its reciprocal are positive. What is secant the reciprocal of?
Cosine?
Cosine. So is cosine positive in the second quadrant?
No.
Nope. So we got to make this negative. So negative square root 2 is our answer.
So all of these are like sine, tangent, and cosine are like the positives. But like let's say I have cosine, and let's say it's asking for cosecant, and then I have to figure it out for cosine. You know what? Never mind. I'm so confused on this part.
Okay, so here, all of them are positive. Everything. In the first quadrant, everything will always be positive. So if you're in the first quadrant, you don't even need to worry about the signs. It's always going to be positive, no matter what it is, sine, cosine, tangent, anything. In the second quadrant, only sine and its reciprocal, which is cosecant, are positive. So only these two are positive in the second one. In the third quadrant, tangent and cotangent are positive. And in the fourth one, cosine and secant are positive. Everything else is negative. If we were looking at cosine, but we're in the second quadrant over here, cosine is negative because only sine and its reciprocal are positive. If we were in the third quadrant down here, and we were asked to find the sine, but we were in the third quadrant, is sine going to be positive or negative in the third quadrant?
Negative?
Negative, because only tangent and cotangent are positive.
Okay.